there's one exhibit at the Museum of Natural History that is by far the scariest thing in the entire museum that I am confident was put there entirely to terrify children.
Oh,
So if you go into the big room with all of the ocean life, in the far back corner on the left, behind some stairs, it's the only exhibit that doesn't have any glass in front of it. It's very dark and very spooky.
she's setting
And
it up
there's
really
this
well.
giant squid
Oh,
fighting a sperm whale in the darkness. And it
wow.
is straight out, like, it gave me nightmares for years in the best way.
Hey, Backkeeper, what's on tap? Well, buddy, pull up a stool because it's time to pour another episode of the Helical Brew. Today, Madeline Wolf on racks, robotics, and building the automated lab. Welcome, everyone, to the Helical Brew. We are joined today with Madeline Wolf, the founder of the Automated Lab, and we're looking forward to getting to know you and what you're doing. But first, a couple of items to introduce our series. This is going to be part of our Automation in the Wild series, where we've been talking with automation professionals and folks that are working in the industry along with us. We are all part of that industry as well. And we're titling this episode of Blueprints, Bots, and Breaking In, Building the Automated Lab from the Ground Up. And so, Madeline, welcome.
Hello, hello. Here I am, straight from the wild.
Straight from the wild and straight from Brooklyn, as we know it. We are
Yes.
coastal. We are coastal this time, or at least Eastern and Western times, Pacific time zone only on this one. And in fact, that's actually how it is. If I could take a screenshot right now, Sura and I are on the left, and y'all and Elizabeth and Madeline on the right with the way the videos happen to come up. So it was relevant to the country layout here. So. Welcome back to Automation in the Wild, where we explore how real automation professionals get it done, whether it's building systems, fixing bottlenecks, or rewriting the rules of the industry. Today, we are joined with Madeline Wolf, automation engineer, product leader, and the founder of the Automated Lab. And we're looking forward to talking with her more. Just a little background on Madeline first, though. Madeline's journey goes from early work in assay development, automation science, and to leading platform innovation at Ginkgo Bioworks, which I remember visiting Ginkgo very early on in my time with Precise Automation, now Brooks, and I got that was a lot of fun. But I'll tell those stories later. And now she's building on her own consultancy that's not just delivering projects, but educating the next generation of automation engineers, which is fantastic. I think, passing on the knowledge is what's going to make this industry move faster. Super happy, super excited to talk more about that. So, Madeline, a little icebreaker. What's your and we'll go, of course, in the background in a minute here, but I always like to start with the icebreaker. What was your first real automation win? A moment when something finally clicked, or maybe exploded in a good way?
Minimal explosions, I think. But the first thing that comes to mind is arguably not automation, but it was sort of the first moment that made me realize how exciting automation could be. And that was in my undergrad working for a PI in an evolution lab where we happened to have a little molecular biology corner where I was the one representative teaching the grad students how to get it done. But my PI was a really big fan of Illumina sequencers, so next-gen sequencing, which sounds very silly. But his reasoning was the work we were doing and studying evolution through spider biology, through collecting bugs in the Hawaiian Islands, was made possible by using DNA sequencing of basically one sample to figure out what was the community breakdown of this, area within Hawaii. And they could do that and they compare against a bunch of other locations to figure out how these insect communities spread. And if you compare that to ye old Sanger sequencing, it was a fundamentally different type of science that couldn't have been done with previous technology. So right now you can do really high depth sequencing of, thousands of bugs in a single tube and get meaningful information out of that at a relatively cheap rate in a way that, physically impossible with Sanger. And so he got me really excited about how technology can not just speed up science, which is, I think, what people first think about with lab automation, but fundamentally change the science that we can do.
Yeah, and probably got some folks over at Illumina like looking at, wow, okay, this is an interesting application of our technology, because they never have it all in the bank when they're releasing an instrument on into the wild, as they say. So yeah, super cool.
Yeah, I guess that's really automation in the wild.
Well, it's something that clicked and exploded in a great way,
Yeah.
because they realized how useful it was, and use it over and over again. So, well, fantastic. Well, maybe give us a little backstory on how you arrived at what you're doing now. I'm always a little bit jealous of somebody who's in like a consulting role and sort of doing their own thing, because I mean, I think deep down, a lot of us want to do that. And I mean, as we were talking earlier off air, we get opportunities to consult, and that's one of the best parts about the job, is enabling folks with technology to do things they haven't done before. But doing it kind of in a role, where you are complete control of what you're doing, and what projects you want to work on. So give us a little background on how you arrived on that.
Yeah, my short version of my career is that I've been getting increasingly meta over time. So
I
I
love it.
started out in school studying molecular biology, and as you can see, got really interested in genomics early on. And so my first job out of school was just working the bench doing assay development at a company that was pairing cancer patients with clinical trials. So as part of that, we were developing some cancer screening processes. And as luck would have it, we had a really fancy automation system there. And also, it was a tiny little startup, which means I got way more responsibility than I deserved at the
Oh yeah.
time. Which was, I think, really formative for my early career, because I got to work with this automation. It's also a small team, which means at some point you get tired of waiting for someone else to fix a little bug here and there. And so eventually I bugged the automation lead, who happens to be my current co-founder, actually, of the automated lab, to start teaching me things about automation. And so I learned some liquid handling here. I learned some integrated systems work there. This wasn't really, in retrospect, I'd probably designed the system differently, but it was a really cool system where we had end-to-end NGS. So we had a pre-amplification section, a post-amp section. It was all connected by 2 robot arms, very fancy. And that was a really great intro. And so from there, I moved over to Zymergen, which was a synthetic biology company based out of Emeryville, California. And they ran automation very differently than I was used to. And I think most lab automation engineers are used to, where we were really providing a service to the rest of the company. And synthetic biology is really neat because there's a ton of different disciplines all working together. It's not like it's just really specialized in protein science or really specialized in DNA. It's getting a lot of different teams working together really efficiently and doing all the logistics around it to make them transfer off nicely. So it's a really neat experience as an automation engineer, where you get to work at a large scale and figure out how to make these technologies, which are already really complex if you're just working with, liquid handler, one work cell, and try and figure out how to make it sustainable when you've got 20 liquid handlers and 20 work cells. And then, even to make it crazier, we were developing our own in-house automation technology, because our goal was to be able to run factory scale lab automation, which there's more products in the market now that can start to address it. But at the time, there was absolutely nothing we could buy that could fit that need. So before I was even on that team, they had some software engineers and mechatronics engineers and robot specialists building their own technology from scratch. Mm-hmm. I think y'all actually have had Will Serber on in the past, so you've gotten the whole story there. But I joined that team as the first sort of traditional lab automation engineer, when it was just software folks and hardware folks.
Oh, okay.
And so that was a really fun role, because I joined right as we were getting this really fun inflection point where it went from being a strange little prototype to something that we were using in production. And I'm sure y'all have worked with, early development systems of various kinds in the past, and they are janky, we'll say. And so I got to kind of follow through as this automation engineer when it's finally ready for real production use, both working with this new technology to design processes like I would with any other platform, but then also getting to turn around and talk to the software engineers and hardware engineers and say, here's what we need to fix to make this sustainable long term. Or really just advocating for my perspective as someone who's used to other off-the-shelf technologies. Because when a software engineer designs a tool, they're thinking from the bias of a software engineer. And they're like, yeah, everyone knows Python. It's very easy to write protocols this way. And then I'm coming saying, yes, we could do it that way. Who do you want the user to be? Because someone like me is used to doing something like drag and drop. Of course, this is all changing. Like the industry has changed so much since I started working on that. But anyway, I followed that journey for quite some time. We were acquired by Ginkgo, doing a very similar thing. And after many, many years of being on a really cool adventure with that team, I wanted to do something extremely different, which is how the automated lab started. It actually started first as this idea around automation education, and then we kind of backfilled consulting on top of it because free education doesn't pay, it turns out.
No, sadly. Unless you can get adopted by the state or something to put you into their program or something. But yeah, other than that, it's tough.
Yeah, and so it was sort of a real passion project that actually started as just sort of a little summer activity. And the idea behind the Automated Lab is to publish just very basic lab automation educational information that isn't too specific to any particular technology. So right now, if you want to learn about lab automation, generally speaking, you just end up in the right place and hopefully someone teaches you, or you figure it out by breaking stuff, or, you know, if you're lucky, you pay a few $1,000s and you fly it to Reno, and then Hamilton teaches you how to use Hamiltons, or, you know, TCAN
Sure.
teaches you how to use TCANs. But there isn't as much information about, well, how do liquid handlers work in general? Like, forget all the specific software, forget the names of their 8-channel head and their 96-channel head. Like, what is a deck? What is a script? What are the components that go into this? What's a liquid class? That's my favorite. And so we've been writing a bunch of information and publishing it at theautomatedlab.com, and also working with a bunch of really cool folks to help them achieve their automation dreams on the side.
That is absolutely fantastic and something the industry really, really needs for sure. And the ability to pull all that together and have a background and career that allows you to bring all that together is also fantastic. So,
but I think it's also filling a gap right now, because like you said, the only way to learn this, because there isn't school for it, we've mentioned that several times, is to have someone mentor you through it, basically, or to fuddle your way through it over years to get it. So I think what you've created is a really great resource, because this is very interesting stuff, right? It's a great like portal for putting together something informative for people.
So glad to hear it.
Before we get into the first segment, I just wanted to mention, a thought from when you were talking about your background at Ginkgo. It seems like you really brought some balance to the force there, because I've seen it over the years where companies that come from the space that I started in, heavy industrial automation, right? Big robots making big things, or small robots making things in clean rooms, all of which are being driven by a completely different business model than research, right? They're being used to produce things. That's a very different thing. So I could totally imagine, coming in there at that stage, you've got a bunch of folks that want to produce stuff that looks like a car factory or a little car factory. But then you've got science and research, which doesn't have the same kind of requirement when the rubber meets the road, right? And you're actually using this stuff. It's two different things, right? You're changing things more frequently. You need to be able to go in and make adjustments. Whereas once you make a factory, it's like, you don't want to make adjustments. You want to run it. And I kind of saw these two mindsets colliding in different stages of my career, from, when that gigantic GNF system was built in San Diego with robots that are 2 meters long, handling microtiter plates, but that was the beginning of an era, but it sort of had to balance out. That was one extreme. And then, that came up again when I saw these modular systems, the racks. Originally, I'm like, wow, that looks really industrial. It feels really industrial. What's going on there? So now it's great to hear that sort of your perspective on it. Because, the racks era is real. That's the first segment that we have down. I wanted to just talk with you about your experience with that. We talked with Will, of course, as you mentioned, and that was a lot of fun, because I know he was involved from the very beginning. Like, he was also we need like a new copier. We need things like that. When he first started out, he was telling stories.
Worked his way up from the mailroom, I'll tell you.
Yeah, right. And then he's just like, well, I'm a physicist. Okay. On top of that. So that was, to be able to kind of pivot, right? Really pivoting. But, from your perspective, what were the rack system or reconfigurable automation carts at Ginkgo? And like, how did the teams approach modular lab setups, right? Well, how did it change the way they approached it, actually?
Yeah.
Right, because modular lab setups have been discussed before the racks came up. I think Will did a great job of finding a niche, right, a need where it wasn't just one automation engineer in a lab saying, hey, I'm going to make it modular, and really kind of creating a product. So it's interesting to get your take on being at the forefront of that, how it changed that whole dynamic.
The modularity thing is really interesting, and it's glad to hear y'all have discussed it before, because for the longest time I had a whole spiel when it came to modularity, almost like teach people what we even meant by it in this context. And now I think that modularity has become a much broader word within industry, and I've actually almost been rethinking how I refer to the modularity there, because what are we actually trying to get at with the modularity? And with the case of the Rex, the big thing we were trying to solve for was the complexity and the dynamism, I suppose, of synthetic biology, and particularly being a provider in synthetic biology, where we're working with external clients. They're coming in. We have a lot of processes established, but they might have a different microorganism they're working with, a different target molecule. You're doing a lot of assay development very quickly to onboard their processes. And you can, if you're a human being, you can kind of do that through sheer brute force. But if you want to be scalable as a business, you want to automate it. And so what technology can handle that? And the standard of lab automation hardware is so much about, bolting equipment onto a table and getting a process working pretty well. And every single step along the way, there's just a ton of waiting around. I'm sure people know much more about why than me, but ordering parts takes a long time. Actually assembling it takes a lot of time. If you don't have a really solid team in house, waiting for field service engineers to come in takes a long time. And that made automation almost a non-starter if we did it the traditional way at Zymergen. And so when I first started, I was doing more traditional automation where we had a bunch of smaller function-oriented systems, so small, traditional, off-the-shelf work cells and whatnot, designed to do, rather than here's the NGS system, it's here is a sample rearray platform. And we've made it so flexible that whatever labware you want to use and whatever your work list looks like, whether it's 5 plates or 50 plates, put them onto the system and walk away, come back. It's all part of the same ecosystem. So that's where the actual functional production world was starting within Zymergen. And so with Rex, the idea is how do we actually scale that up so you can get the longer lock away time and you can string more processes together, but actually do it on this more traditional hardware. And thankfully, by the time I joined the team, the folks, even though they were coming from more of an industrial perspective, really figured out a lot of the secrets of lab automation. And so it's not like I was coming in there and arguing about which robot arms to use. There was a whole study, for a year of which robots do we use. And the biggest assumption we have underneath it all is that we wanted to be able to work with almost any device, whether that's the lab device or the robot. If at some point we realized that we needed to fundamentally change our transport system, like we use that really fancy MagnaMotion track right now, but if we wanted to change that out, it is constructed in such a way, both on a hardware and a software end, that we could make that change. And maybe there will be a reason for that. If you want to stick the whole thing in an anaerobic chamber, okay, we're going to need to make some hardware changes, but that is fundamentally possible. And all of the decision making was around understanding and accepting and making peace with the fact that we were not going to have a plan, which,
that sounds like automation engineering.
Right.
That goes over well in a meeting, Oh, start with we don't have a plan, but let's get going.
And building all the infrastructure around the fact that wrangling humans is hard, and there are different sciences and different industries where it's easier and more reasonable to say, hey, we're processing patient samples. It's not going to change that much. Let's design a system that's going to do that at the highest possible throughput, or really flexibly, or really robustly, whatever it may be. And that's a totally different environment where more traditional lab automation has been serving that market pretty well for a while. And it's R&D, and I think synthetic biology being kind of an extreme case of this, where you can't plan ahead because your clients are going to change for sure. The trends within science are going to change. The devices that people want to use. So if we decide we want to pursue a vertical where we want to do a lot of mammalian cell work, they're going to want high content imaging. And that's going to be totally different for what you did for your fungal cells over here, where the problem was they're too goopy in media, right? Like the problems are just constantly changing. And once you kind of build around that assumption, you can I guess you end up with Rex.
Yeah,
Yep.
I remember when they were first sort of like developing. Well, I looked at it mostly from the robot and the hardware perspective, from the outside looking inward. But I remember, yeah, they were. I felt like they were involving the user, which internal at that time, an internal customer, mostly, or an eventual acquirer. But they were an internal customer before they got acquired, really, I guess, in a way. But yeah, I felt like they were like the customer was along for the ride, right? They were,
Yep.
involved in that and giving feedback, which is not always the case when defining a platform. Were there any lessons learned that you takeaways from kind of managing the modularity in the real world?
Yeah, I think that the biggest one, and it's a problem that's not totally solved, and I think it's very interesting. And, even with all the current flashiness of AI science, it'll continue to be really interesting, is how do you think about scientific processes and wet lab work from a more functional and device agnostic lens? Because as an automation engineer, you're generally doing that, right? Someone comes to you with a process, they want to automate it. You are thinking, okay, well, we've got these liquid handlers, we have this plate reader. I know how we can apply those technologies to your science.
It's a puzzle.
Yeah. And so when you get even more extreme on that front and you build a system that is modular and is built to be more device agnostic and more function forward, there's a lot of education, and I think of it as like a customer therapy involved in and how do you work with science teams and individual people to reconsider the work they already do day to day, where you're really focused at show up in the lab, pull these reagents out of the freezer, pull these reagents out of the fridge, put this one on ice, keep this one dry, right? There's just so much you're doing every day, and trying to remap that into functional work. Where's the liquid handling step? Like, are we moving which volume of which reagent from place A to place B? And how important is accuracy? How important is reliability? Do we want to get this done quickly and really uniformly, or do we need to get it done as perfectly as possible? From the scientist perspective, this actually matters, but it's not how they're thinking about their work, especially when they get to hold their own pipette. And so I had a lot of conversations over a long period of time with folks about trying to think about science from a very different angle. And there's a lot of resistance in it, which I empathize with a lot as someone who started out at the bench. You're so focused on the work you're getting done that when someone says, but what if we took your personal experience out of it entirely? That's very abrasive and not very constructive. And so
Here's
you
your
can
PO.
develop.
Yeah, I'll order right away. Yeah.
Yeah. And so there's a lot, you can build a perfect automation system that does everything right every time. But if you can't resolve all of the human engineering around it, it's not going to work, because there's always going to be some step of the process that is manual. You can chase the total automation as far as you want, but at some point a human will be involved, and we need to figure out how to bridge that gap really effectively to have really effective automation.
Fantastic. Well, I'm gonna put a question behind the gold track you just laid down, because I think that was really a great answer to a question I wanted to ask. But and that was, what did you learn about balancing innovation with reliability when labs depend on your systems daily? So, cut and paste on that one. But that was I think a really, really good insight into that, because that is ultimately the question when it comes to these systems, is, the reliability that folks were used to in the 90s, especially for like, oh, well, look how I operated for 16 hours with uninterrupted operation. Fantastic. How about 16 days or 16 months, or something like that, right? And that's what
It brings me back to that first anecdote I had with the Illumina sequencer, because the work I was doing in that lab to develop this library prep process was deeply non-automated. And so I sat in front of a thermocycler with strip tubes as we tried to optimize the number of cycles to different PCR steps throughout the process. And I would just sit there late into the night on Thursdays and Fridays, waiting in every cycle, just taking one strip tube out and timing whether I could make it to the bathroom and back between, cycle 29 and 30.
Yep. Yep.
And
See, how much time do I have?
That's so much what science is built on. And people who have had so much of their experience doing work like that, it's a huge transition to reconsider what science can look like when you aren't doing all those annoying tasks.
Yeah, it's babysitting it really at the end of the day. I mean, I'm okay with that in an early stage robot software thing I'm working on, but boy,
Yeah.
I don't want to hand that over to somebody else or do it myself, let alone for
Well, it's
that.
the difference
So,
between true automation and, actually just
yeah,
babysitting the automation
dabbling.
that you've purchased, right?
Yeah. Yeah, and so many of us, we have the story of, well, look at this fully automated system. So what's that person doing? Oh, they're just pushing the tube over. Every once in a while, it's not quite
Millimeter.
upright, so
Clicking
we have
retry.
to. Yeah, right. Gotta have a couple of spare mice there because this one's going to wear out in a week, from all the clicking of retries, right? Yeah,
But that's the robustness you expect at this point in time in the evolution of automation, right? At the beginning, when we're fiddling, when we're trying to figure it out, it makes sense to babysit. But at this stage, we should have all the pieces we need to actually build robustness into it where you can walk away and you're not working on this timed period where you're like, oh, I can step away for a minute before I have to transfer it to the thermocycler,
Yeah, that's the hope, certainly.
And experiences like you were talking about from the Ginkgo and Zymergen experience, I think that is those projects are what are moving it forward, right? It's raising the bar, because then if everybody's seeing how the bar is raised, their expectations are going to be for the new bar, not the old bar. And I think that's changing things. It's driving companies to innovate within their instruments. Certainly I've been involved with a product for a lot of my career that I've seen the reliability go up, tenfold in the time I've been involved with it, right? So, that's huge, right? And it's all being driven by customers. And that's what that's the most powerful driving force, I think, when it comes down to it. But
It's funny that you say that. It's kind of my secret reason behind starting the automated lab is seeing how small this industry is. It feels bigger sometimes, but it really is very small, and you can have quite a
yeah,
bit of influence by making
Mm-hmm.
small changes. And I had an experience with working on the rack team of just sort of working on this technology, and people being exposed to it would change a little bit of marketing language here and change some features there and other products. And my big hope with releasing the automated lab was not to single-handedly change the landscape of automation education, but to encourage a lot of other companies and a lot of other individuals to start sharing information. And it's been really cool to see in a short period of time how just kind of one person showing how things could be really changes a lot of communication within the industry.
yeah. No, that's awesome. And really, you're talking with their customers, right? Ultimately, the vendors, I think you're getting the attention of the vendors, right? Because you're talking with what's going to be their customer ultimately, and I think that's can be incredibly powerful message that they're getting to future users and current users and future users, right? That want to step up to the level of the game, and learn more about it. Well, transitioning a little bit, you going from engineer to product strategist, right? And transitioning from automation engineering to product management. How did that unfold?
Yeah, it's very slowly and through a lot of exploration. And part of it, I think, is almost redundant in that I think any good automation engineer is on some level a product manager. They might not call it that, but a lot of the skills are there because automation sits in this very strange place where, yes, there's a lot of engineering involved, but you can't get anything done on engineering alone. Like we were just talking about a moment ago, right? There's all the human side of talking to a scientist, requirements gathering, figuring out what they're actually asking for, right? They're saying, I want to automate this process, but your question is, well, what are you trying to achieve here? Does
Yeah.
it need to be faster? Are we capacity limited? Is it really dangerous? Are we just trying to protect you from biohazards? There's a ton of things they could be achieving. And sometimes the answer is we actually don't need to automate this at all. We should have just bought a different piece of equipment, or this workstation in the lab should actually be over there because that's where you spend the rest of your day. Like there's solves that aren't even automation oriented. And a really good automation engineer is looking for those kind of problems. And so moving into product management was something I did after being on that rec team for a while, because I was kind of playing, I didn't realize it at the time, but I was sort of playing this hybrid role of automation engineer and product manager. Because like I said, I got to actually develop the processes with this technology, but I also got to then work with the other engineers on the team who were building the product to say, what are we going to do to move forward? And that's a really cool project because it's so long term, and it's not traditional product management in some ways because you're not dealing with this external customer, but you are considering all the customers within an organization. Ultimately, it did transition to being external customers where we did start selling the technology. But along the way, there's balancing of all of these technical requirements, of the science, right? But then the technical requirements of the software, the technical requirements of the hardware, balancing those things against each other because those develop on very different timescales. You can make an ask of a software team to turn around a ticket in a couple weeks. And if you ask the hardware team that, they are going to throw something at you.
Yeah.
And then trying to turn around and, you're debating within the development team of what do we need to get done at what time and what goals are we trying to achieve, and then turning around and kind of protecting them from the end users who are mad that the thing isn't running perfectly right now. And so that role kind of naturally transitioned into product management, which I forget when it actually formally transitioned. But it was more leaning more into the human side of the automation engineer role than the pure engineering side.
Yeah. Did you find yourself, so I mean, certainly there's the peacekeeping element of product management, but also did you find yourself advocating sometimes for your own team, but with the customer, right? So presenting, the solution when they're pushing back maybe, but also advocating for what your team has come up with. But then on the other side of it, listening to the customer going, they have a point here, advocating for them with your product development team. Did you find yourself jumping between those two roles in that job?
Absolutely. And I think one of the best skills I learned when I was a baby product manager was learning how to gather more evidence from the customer. Because coming in as sort of like kind of the biologist on the team, so to speak, I often had an empathy for the end user that some of the folks who have software backgrounds and industrial automation backgrounds wouldn't necessarily have. Things like the concept of user error. There's always a debate within engineering as to like how real is user error, right?
Yeah.
And on one hand, like users make mistakes all the time. Of course they do. On the other hand, as an engineer, it's kind of your job to make it impossible for there to be user error, right? And you're balancing those two things. But I've been in the lab and I, especially early on, made tons of user error and the kind of things that feel very silly to then explain to someone later. But now if I look back on those experiences as with an engineer mind saying, well, why did we set up a situation in which this junior assay developer was able to make mistakes every day? Like we're doing something wrong because the user's going to make mistakes. And so back to the original point, just coming in with that sort of personal empathy and background and trying to advocate against the development team who's at any point in time overworked, has way too much to do, and has a long list of features they need to deliver on. Gathering more data from users, both on the qualitative side of, this person's going to stop using the tech if we can't address some of these challenges in some way, but also balancing what is the quantitative effect of this? Are we getting more errors from XYZ root cause? Are we seeing that there's actually lower throughput because people won't run the system overnight because they have this fear? And actually gathering that data and gathering that evidence makes you a lot more effective at advocating for the customer than just being very earnest.
Yeah, absolutely. I mean, one of my favorite things to say was, well, look, at the end of the day, the resource we're talking about, that could add this feature, they're balancing between two different things: fixing bugs and creating new ones. So, all right. I mean, look, it's like raw unplugged with your customer at the end of the day. And I when you're confident about it, they don't mind that. And, I would say that and I'd be like, well, look, is it worth the risk or can you work with it? And then you find out and you're like, no, we can't work with it. Okay, then we'll work on putting that in. But we could be fixing other stuff at the same time, it's just resources are limited at the end of the day. So, yeah, but sounds like,
and that's a good point you bring up earlier about like user error, because user error is very subjective, right? Error is error. It's just how you categorize it as user versus whatever else the categories are. So it really has to take an agnostic approach to just be like, okay, we have an error. We don't have process controls to deal with that error, right?
Yeah, my favorite is like placing something on a liquid handler deck. If you put the plate in the wrong spot, that's user error. But what could you do to make that not happen next time?
Right. You could also program, a script in a way that it could identify that.
Barcodes,
wrong.
labels. Yeah. I mean, stickers go so far in lab automation.
Yeah.
Oh, yeah. Barcode reading.
Tune in for our next episode of How to Make Automation Go Wrong.
The system stopped when I put the wrong plate in. it's an error. They could call that an error
Yeah.
too. It's like, well, no, it actually saw that it was the wrong plate. So,
Yeah.
maybe it wasn't.
And
Yeah,
I think
it's
stickers actually, I joke, but it's absolutely not. Where on the rack system, so there's a magnetic track that carries plates around like a little roller coaster, and these pucks are just these black metal pieces. One of the very important items we added to our checklist in deploying these systems is putting a little A1 sticker on basically every single nest in the entire system.
Crosshair.
Yeah. Because
Oh.
even when the system runs perfectly, at some point,
right.
someone will pick up a plate and put it back for demo purposes, for testing, for whatever.
Yeah.
And when you have this big integrated system, one mistake here, even during development, worst case scenario, ends up jamming a device somewhere down the line. So if you flip around a plate, now it doesn't fit into the qPCR machine because it's got a special slot in this corner only. And now you have a device that might be down for a week or a month, right? Something as simple as just having an A1 sticker in the right corner. It's annoying. It feels silly. It feels like surely this is below my pay grade. But it is one of the best things you can do to actually keep a system really robust.
Yeah, for
People
sure.
are good at doing the right thing when you make it easy for them.
Well, it's also kind of tells you that you can't fully abstract humanity and what it could bring to the table out of a process. For whatever reason, a system could be running perfect and someone is like, oh, but look, I want to show you this cool plate. Just totally demolish the whole thing.
Yep.
Oh, we've
And
seen
that is one of the other big trips in making a big system like that, a really like large scale integrated system, is making sure you don't back yourself into a corner where you as a human can't do things.
Right.
Right? It becomes tempting, and I think as everyone here probably knows, like the more it's kind of easy to program robots and it's kind of easy to tell people what to do. But once you try and join those at all, it gets really hard and messy. And so there's a temptation, the more you automate something, to make it just really insular and make it, bring it to a point where it's going to work so perfectly and everything is so seamless and the data comes out organized every time, as long as no one ever touches it. Well, now you have a fatal flaw because someone will always touch it.
Yep, that was as far as like the early mid 2000s was a really big era for completely enclosed machines. Like, maybe you had a door where you could get to the back of some devices, but the robots inside were so dangerous. You had to lock it up like a bank vault. There was no way to, like, it was just a safety thing. It wasn't, so users were naturally kicked out of the room automatically just on that requirement alone. But it's interesting. Yeah, I think the rack system for me was one of the first times I saw, like, okay, the robot's not going to like tear your arm off. It's got a door on it. You can access the instrument just like you would a normal bench. But the door is normally closed because, right, you're, ideally just trying to work in an automated fashion. So, yeah, I could see they were trying to balance that out. Approachability versus just outright no humans allowed, kind of thing.
Yeah.
So
those doors are actually part of, I think, why those systems are so special. So one of my favorite things about working with a automation system designed for a company that is using it actively is it's I would say always going to meet your needs perfectly, but it is, you can always advocate for yourself, right? And previously at that cancer genomics company I worked at, we worked on this fancy system, and it was very, I think it was based on like thermal momentum. It was very traditional parts. A lot of people would not be surprised to see it. And there was some really nasty ergonomic issues with the system. The main one being we were handling human samples, including blood, and I often was loading plates filled with blood onto and off of a plate hotel, which was placed on top of a table. Extremely normal setup. However, I was probably a foot too short to be doing that, but that doesn't change the fact that I still had to do it. And this is all fine as long as your plates are perfectly sealed, but every once in a while, a plate sealer becomes misaligned. And so there's maybe a column that's just partly exposed. And so I was very aware of the fact, thankfully, there were never any personal biohazard issues, but I was very aware of the fact that I was putting myself at risk during development of just dumping a plate of blood on my face, which, not an ideal circumstance. And so I contrast that with working with the racks, where I personally love the doors, and a lot of the devices actually are on drawers themselves, which feels like such a small little detail. But it means working with devices is both far more pleasant than on a lot of the systems I'm used to, and also just a lot safer. And it's going to reduce the amount of times, an engineer breaks something because you're working at strange angles. And, I spent a lot of my time early on crawling in between those large robots in the middle of the system, because you generally structure a bunch of devices around a robot arm, and working with a system where you get to kind of personally advocate for the day-to-day use of how that's going to work. Because the end user is part of it, but also someone's got to keep it running. Someone's got to maintain these devices. You get a large-scale system, well, preventative maintenance is happening on a lot of these devices once a day, even, or once a week, once a month. You got to consider all these factors if you really want large scale automation.
Yeah. Yeah, for sure. One of my favorite videos I saw was an end customer doing a kind of a documentary on the different types of automation they've owned over the last maybe 15 years.
Ooh.
And it was just because they were doing a product video for the vendor that recently sold them systems, but they included some great video. Literally, the guy was climbing into a gigantic 2-meter by 2-meter biocell. And you remember the biocell, right? It had a semiconductor derived robot in the middle of it. And it was basically a repurposed semiconductor robot that was just doing this on plates, right? Just like, going from one system to the next. It was the original Velocity 11. But the thing is, when you surrounded the whole robot and all the hotels by this instruments in this cage, you had to crawl into it to do anything, and it wasn't that tall. So I thought that was really a great example of how there's been some systems out there that very cool to look at when they're running, but boy, working on it's tough with the ergonomics issues. I mean, do you have, just before we switch gears to your why you started the automated lab, do you have any advice for folks looking to enter product strategy?
Oh gosh. I think the biggest thing, at least for me, was really getting to know a product first. I don't think I could have gotten into product management and product strategy without first having the experience of working on a product that I really believed in. Like I talk about it now. I don't even work there anymore. I still talk about it because I think it was really cool and solves
part
a
of your
lot of
career,
really
right?
big
You spent a lot of
problems.
time thinking about it. So yeah, absolutely.
Yeah. But I think, as you learn these skills, it helps to do it in a easier environment of actually getting to know technology first. And part of that for me was, again, my increasingly meta career, right? I've worked at the bench, I've worked, loading automated equipment, and I've worked programming automated equipment. I've got a lot of opinions about how you should build automation equipment.
Yeah.
And I think for me, that was a really strong entry point, and it makes it easier to apply those to other cases.
Oh, fantastic. Well, switching gears over to the automated lab and what you're doing right now, was there any, I mean, I think we've discussed a lot of it, but just to put it into the context of a question, was there a gap, or what gap did you see in the industry that made you launch the automated lab, a specific one, or just sort of that aha moment?
How long you got? No.
We call in
Yeah, so
Riverside. How much storage do we have? No, we're good. We've got plenty of time. No problem.
no, there's a few answers to that. One is I was really lucky to spend a lot of my career on a large automation team with diverse expertise. So working somewhere like Zymergen or Ginkgo is relatively unique within lab automation, where I think it's a lot more common to have 1, 2 engineers who kind of keep your 1 or 2 liquid handlers running, or your work cell, or even, you're a scientist, but also you kind of moonlight as an automation engineer because you want to make your process more efficient, right? That's almost sort of the platonic ideal of what an automation customer is, right? Products are so easy, a scientist can do it. But I got to work on this really cool team with like 40 people, plus or minus, all specializing in different equipment. Some folks who purely did maintenance, some folks who purely did development, some folks who aren't like traditional lab automation experts, but were programming drivers. And so they had a whole different insight to these devices. And so I got to learn a lot. And it drove me crazy to realize that there were people on our team who were solving the same problems I had been trying to solve at my previous employer. People who are, frankly, far smarter than me and far more experienced than me, who are still trying to solve the same problem, because there's no way to share, this funky little error code right here on this special device. There's actually a trick to it. And it's like a weird little typo. As long as you know X, Y, and Z magic trick, it's never going to be a problem for you again. And really the only way you can solve that is just by figuring it out again and putting, the best guy on your team on solving that problem. And that's absolutely absurd. I spent about 10 years of my life out in the Bay Area, surrounded by the world of software disruption and open source. And I think I was so used to that it drove me insane that we weren't just getting the same benefits out of lab automation that we can get out of the modern software world, where every software product you have, there's somewhere in it that is based on an open source library somewhere.
Yeah.
And that's making our technology so much better. And so I felt very strongly about that. And there was actually a long period of time where we had considered just publishing some of this information as part of Zymergen or as part of Ginkgo. But for some reason or another, it's just never going to be your top priority. And there's a lot of good reasons for that. Like you're trying to keep a business running, right? And also, the world of biotechnology and of pharmaceuticals are so much based on the core principles of trade secrets, right? And IP. That is how these businesses work. We're now, if you're an automation engineer, saying, what if we just published all of our liquid classes just as free assets? A lawyer's going to look at that and go, that looks like a trade secret to me. I don't know what this is. And I understand that, right? Like, what do they know, right? It's just so much safer to defend that information than to share it.
It's also fuzzy, right? It's easy to know what IP is in the context of like scientific R&D.
Yeah.
But when it comes to like trade secrets or this cool new table I built that then, you see LabSite making it into the market, it's very hard to understand like what's actually something that we can protect, right, in this industry.
Yeah. And if you think about, a library prep liquid handler script, right? That's something that's going to feel a lot like a trade secret. I think there's a good case to say this is our trade secret. This is our special library prep for our special process, and all the volumes and times are something we spent a whole lot of time developing. So how much information do you need to strip from that script before it's no longer a trade secret? Like these are very genuinely challenging questions. And
then
so
the whole caveat of I thought of it and it's awesome, so it's a secret.
Yeah, I'd say it's always a good
My
choice
idea.
to hide it, but it's tough. And as someone who has tried to advocate for sharing more information in the past as part of one of these large companies, it's a real uphill battle. And it's not necessarily worth fighting when you're like, well, I got a whole other job to do. I can only spend so much time with legal before we're both wasting our time. So challenges like that, and having this unique set of expertise, I really just wanted to do something. And I had enough flexibility in my career to have done, I think about 6 years at Zymergen and Ginkgo collectively, which is a long time in startup years at least. I really wanted to do something very different and just kind of show people that it's possible to share information in a way that is not trade secret-y, because part of what can encourage a company to realize they can publish this information is, one, seeing someone else do it so you have something to point to and show that, like, well, I guess that looks identical to what we would have said, so how secret can it be? And two, showing there's an audience for this, and this could be valuable marketing material for folks. And I have talked to companies who have gently adjusted their marketing strategy to be more open with information, and that's something for me that I'm extremely proud of, because
Gently adjusted.
Gently adjusting.
That is something to be proud of. It's really hard to get companies to, because, they all have to sign off on things. I think I've had many vendor relationships, Elizabeth as well, like who I've carried and brought into different companies, and I can't even give them like something they could use on their website without legal coming up to me and being like, no, we need to get this approved. It's very frustrating.
Yeah. And it's also, I think it's why it's really exciting that we're now, Ginkgo is now selling racks externally, because it's totally changed my ability to talk about the stuff that I've worked on. I think is really exciting. When it's an internal technology, it's secret. When it's a product, it's marketing.
Quote of the day.
And also not coming from a traditional product company at all. Like, I mean, this is a business that was around synthetic biology. Both businesses were at one point, Zymergen and Ginkgo, right? They were kind of the East Coast and West Coast competition at one time too. And they, here it is coming together, and they're not even a company that's normally selling capital equipment as a product, but now they are. So that's interesting. So you're not just consulting, you're educating. Why was free education part of the mission?
I am far too earnest for my own good is the true answer, I think. Truly, it was a education first project, which I then realized I had to figure out how to pay myself at some point. And I like writing, I like art, and so I've designed the website myself. I don't write everything. I have my co-founder, Sura, who I'm so thankful I have someone else working on this with me, partly because you need to expand the expertise, Part
it's
of
a
the
lot.
challenge, it's a lot. But part of the challenge of being in this field and not having a textbook to learn from is I have to be very brave to write a piece saying, this is my definitive theory on liquid classes, because I don't know that that's definitively true. It's not like, taking a
It's
Yeah.
biology
definitively
course.
yours, though, so
Well,
technically.
yes. But part of it's being brave enough to say something confidently, because people actually share a lot of information when they can tell you you're wrong. So it's all part of the same mission there. Yeah, I wanted to make the site very, very positive for the industry and try and create something very different, just so that people within more traditional companies had something to point to as a alternative. That's how things can work. So having a site that is purely for educational material, we have some sponsored material, but all the sponsored material is education first that happens to educate the customer about what challenge they're solving. That was something I was doing a lot as a product manager is, within lab automation, a lot of people haven't used automation before when they're purchasing a system. So if we've made something that we think solves all of the problems of traditional lab automation, they don't know that those problems exist yet. And so there's a lot of work within there. So even with the marketing content, it is still education forward.
Do you have a forum where people can interact with you and ask you questions? I don't remember seeing that in the website, but I checked your website.
Yeah. No, we don't. And part of that was around the time I was starting the idea of the site, labautomation.io had already come out, not terribly long before. And so I really view this as part of a communal effort that I'm seeing a lot of people within the industry push on from different angles. And I have no interest in competing with that, right? Like,
Yeah.
it's a forum. There's only so many of us. Let's try and use the same one. And so
Yeah.
this was sort of a complement to that, where the forum is really great for getting information from someone trying to solve problems on the fly. I've seen more and more folks from vendors get involved in that forum and be really responsive, which is really great. And this is providing almost the opposite end, which is general principles on here's the types of robots you find in the lab, here's some language. And I use my experience at Zymergen as inspiration for who the audience is. And so it's a very multidisciplinary world, synthetic biology, as we've spoken about. You've got scientists of various disciplines. You've got the software engineers we're talking to, the data engineers. All these people have a lot of expertise and are very smart people, but also they might not know anything about another domain, right? So I'm talking to someone, I have to get very used to quickly sussing out, like, do you know what PCR is? Do you know what a liquid handler is? Like, where are we right now? I know you're smart enough to understand it, but where are we starting? And writing all of this material from the perspective of whoever's reading it, perfectly capable of understanding, but let's make sure we're using language that people will be able to understand broadly. And so I've been really fascinated to find out who is actually reading this material. It's everyone from lab automation engineers, and especially more junior engineers, to entrepreneurs who want to get involved in lab automation and solve some of the problems we have. But how do you get involved in lab automation if you're an entrepreneur who's not working in the lab already? There's
Right.
absolutely no entry point other than reading people's marketing material. So it's
And everybody's marketing has a different concept or a different word for things that, it's confusing. I find people refer to something with different terms, and you have to ask a lot of clarifying questions to know exactly what they're talking about. And it happens all the time.
yeah, absolutely.
But to kind of go back to what you said, it makes sense at the time that you're building this website because labautomation.io was pretty prevalent. People are on there all the time, and I think it's a very good resource. So it's nice to see that as a compliment. Did you hear about Tatsuan kind of now being part of that forum, and how do you think that changes your desire to actually open up a little forum on lab automation? Because I think it's good when it's a neutral space, and I'm not sure how that's going to play out, or if it's going to play out at all now that there's a banner that says Tatsuan supports this.
Oh, right.
Now we've got a vendor involved.
Yeah, to my knowledge, it's still pretty open. I've talked to Christian at Tetsuan a bunch, and he's seems to be a very passionate admirer of lab automation in general. So I hope it'll continue to be really open. Writing a forum is extremely hard, so I'm glad they're getting some support. If anybody wants to sponsor the automated lab, reach out.
Yeah, but it might now open up a space for you to be a complement to that new space, right? It doesn't hurt, I think, to have more than one place for automation engineers to go and ask questions. And I think as prevalent as Lab Automation.io is become, if you filter, there are only a few, like a handful of people that are always answering questions, right?
Yeah.
So it's interesting to see how more broadly you can reach if you have that sort of part of, not that I'm saying
Yeah,
go ahead
yeah.
and work harder on your website, but you know, it might open up a space for you.
Yeah. And a lot of the challenge with creating resources for our industry is that it is so small that it's really tough to decide where it's worth putting the energy. Because I know part of the challenge with getting more folks using labautomation.io is there's just only so many people, and not everyone is,
Yeah.
a forum rat,
Yeah.
right? And so
And people
I
are
don't
afraid
know.
to say what they want to say because they
Yeah.
don't want to get that. You know, like, I think you and I are sort of aligned in that, like, I love for someone to disagree with what I said because it helps us both grow, right? It breaks you out of whatever corner you've landed yourself in and helps you see another perspective. But not a lot of people feel comfortable like that. So you see a lot of watchers to threads and not a lot of people that actually partake in them, right?
Consumers, not contributors. And actually, I was going to ask Elizabeth, the hub, so Redisoft has something called the hub for its users, right? It's like a user, I don't know, user forum, if you will. But would you
Training
call it
platform. Yeah.
it's a platform, not a forum, right? It's more to provide, or is
It's
it
both.
an area where folks exchange information, or is it an area where you present?
So the goal, and that's the newest thing for the hub. We have a forum built into the hub for general users because only our users can have access to the hub. But I've been, running around the idea of having something more like on LinkedIn,
Some
something
part of it
more open
exposed,
to
maybe,
share.
or maybe like, things you could do
Yes,
with the
but
software or examples or something like that.
yes, something more open to the general user that wants to learn about Genera, not just the users that are currently in the lab using it. So
Right.
yeah, we've had, we're just starting with it, so it's not as used as we wish it will be, and it's partly because a lot of people in the customer side are very concerned about what information they're sharing with other peers, and the community is to engage them and to actually not to share confidential information. Is more like in the user side, how do you solve certain challenges with the systems, with the instruments, with the drivers, things like that, that will also help us to develop the product, and that's the goal with it.
It's really interesting that you say that. I've noticed how there's a couple of brave companies out there that are starting to create more platforms like that of various kinds. There's a lot of experimentation. I think of OpenTrons, they publish their library of scripts, which is of just a very different framework for how to engage with customers than like a Hamilton or Tecan, perhaps. And I do just see a lot of exploration happening with some, again, very brave first players, either as companies trying ways to engage with their customers, or little passionate individuals like myself and the folks running labautomation.io, and even the folks of like PyLab Robot, right, are all sort of trying things that might not become the dominant way that lab automation professionals engage with each other, but they're all slowly chipping away at what we really need, kind of leading by example of, okay, well, if all these other companies are letting their customers talk to each other, maybe we could let our customers talk to each other.
Yeah, right.
Yeah.
But I mean, like, it's good that most companies are doing that, but there are also some that have been doing that since they started. Like Agilent has a lot of protocols online that you can just go and download and pop up on the Bravo, and they've been doing that for like decades and have never gotten like accolades for it, or have never said that like this is a service we offer. So it's I feel like other vendors should have taken that as I don't want to say taken the hint, but taken that as an opportunity to also provide that, because like nothing is really specialized. Everything you provide, the customer is gonna customize anyway, so why not give them templates that they can start without that additional like service fee?
Sounds good to me.
Yeah, I think I mean, I just
Speaking of choir.
Looking through some of the pieces on the automated lab, I just browsing through. I think one of the incredibly powerful things that I don't know if you're seeing it with the engagement of vendors, right? But I think there's one of the reasons for it is the incredible, powerful gravity of tacit knowledge. So when somebody's empowered with tacit knowledge versus just raw kind of overview, but you're plugging away at certain bits of information that require either failing, mistakes, experience, right? When you're giving people that benefit of getting them a little further after reading your pieces, right? That is huge. And that I think it just draws in, right? It becomes part of the conversation. Is I learned this on the automated lab. And I think, I wouldn't be surprised if you see more, engagement, maybe even like, as you said, the brave individuals get more microphone in the whole deal,
Yeah.
and then they're able to make more prolific changes within organizations. Because, a lot of it comes down to like proprietary thing or, trade secrets or whatever. But, there is always an avenue for being open with customers. We see it in robotics all the time, and liquid handling, the same way. I mean, you've got, it just makes the tool more powerful. And certain things, obviously, you need to protect. I mean, you're not going to show how your pump system works, but that's not what people are asking for, right? I mean, I think tacit knowledge is something that a lot, just, you can't cover everything, right? But I mean, for me, I'm a roboticist. I'm not a scientist. So I just like reading the pieces about liquid handling or some of the scientific applications. So I'll be hitting up your website for sure more. And signing up, right? Folks, yeah. So, but yeah, and also for folks that are listening, right? If you want to go visit, right? Call out, shout out, theautomatedlab.com, where you can go visit the website that Madeline is working on along with her business partner. And I'm sorry, who's your co-founder again?
Sudha Golapudi.
Sudha Golapudi. Okay. So, yeah, theautomatedlab.com, where you can sign up and donate as well, and sign up as a I guess what do you have, the membership options, a supporter and a contributor, yeah, on Patreon. So, yeah, very cool.
Very nice.
So you spent a lot of time building this website and taking, time away from the progression of where you wanted your career to go to get it to where it's at. And to that end, a lot of my own engineers know your name, right? Because they know of the Automated Lab and have recommended you to me. I'm curious, where are you going next with either the Automated Lab or, what you want from your career?
I like to think of my career as being kind of project-based, which is not at all traditional, and maybe I will regret down the line. But for me, it was so important to, this was an idea that had been kind of itching in my head for so long. Felt almost distracted by it. And rather than continuing to try and, make it happen in environments where we talked about the reasons why it's more challenging to do it while doing another job, right? Having the flexibility to just be able to set time aside and work on it was just important to me. And so I am, I feel like we've put up a ton of writing. Like there's always more. We have a long list. We could keep writing forever, but probably now, having kind of established this base of knowledge, we'll slow down a little bit on the writing. I need to go back to getting, more experience in the lab again. I'm sure everyone knows, in a weird time. We're in a weird time for the bioeconomy, as people say. And so we'll see what happens with lab automation over the coming years. I think I'm really interested in seeing how the industry changes with, different economic pressures, with sort of the technical landscape changing a lot. I think if you go to SLAS, you can kind of see the distribution of vendors and whether they're newer faces or older faces, and the balance seems like it's been shifting a lot. And so I'm very interested in seeing how the tech changes, because I spent so much of my career getting very passionate about what I think the forefront of technology is, and now I need to make sure I stay at the forefront if I want to keep having opinions.
Well said.
Yeah. So, I mean, speaking of that, what excites you about where the lab automation is headed from your perspective? Like, what's the...
Yeah, one of the things I'm really fascinated by is it felt like this year was a big inflection point of various lab automation vendors releasing or teasing some kind of SDK, like a software development kit or API for their software, which are things that are like very boring. If you're a software engineer, you're like, yes, that's just how the industry works, right? And the answer is no. Lab automation is both extremely futuristic
Sometimes
and fancy,
they don't even
but
exist,
also really
right?
behind the curve. Yeah. I don't have a strong opinion yet on which way things need to go, because I think there's branching happening within lab automation as to, what is your goal with it? Are you just, again, a small team trying to make some processes more efficient? Are you a Zymergen or Ginkgo trying to totally change the way biology is happening on a day-to-day basis. These are entirely different goals that require different technologies. And so I'm curious how people continue to integrate these systems with technology, but with software ecosystems and whatnot, and also how that changes the user base. I have long thought that my job as a automation engineer had a time limit on it. It seems like having automation engineers is a representation of an inefficiency in the technology, right? Like if all of these work cells and liquid handlers just did exactly what a scientist wanted without anyone worrying about it off the shelf, you wouldn't need me to do anything, right? And maybe it's a fiction to think that that could ever be totally condensed. But I do think as technology improves, the nature of the automation engineer will change a lot. And maybe that just looks like a branching into more traditional industrial automation. Like maybe we see a lot of labs looking more like auto manufacturers from a software stack perspective. Maybe we use LLMs to really truly make it just lightning fast to create new scripts. I'm a little skeptical on that front, but maybe. I think so many facets are changing right now that I think sitting back and watching with everyone else.
I think the whole field is exciting. I mean, a succinct answer to that is just so many things are happening and it's super exciting. But to your point, there's definitely different now opportunities for automation engineers to like almost specialize or to add their skill sets, right? I'm with you that, AI can't actually write the full protocol, but it's nice to have templates. And I think we, as we move from job to job, have templates, right, that we bring to new jobs. So that's interesting to see what's going to happen in the future.
Yep.
Very
and on
good
the open source
viewpoint.
front, I really, really, really hope that we can all spend less time recreating those templates from scratch. Because if I go start at another big company again, I've spent hundreds of hours of my career optimizing the perfect liquid classes across multiple devices. I dread the thought of having to do that again. I know I might have to, but
Yeah. Or how many NGS protocols have you written?
Right. Yeah. And it would be wonderful if again, more of that was open source and we just didn't have to waste very smart people's time with recreating the basics over and over again.
Yeah. Do you think there's maybe also a paradigm shift in the business, the companies, like the way companies operate in this industry where they look at the world more from, instead of being the chef, they can be a chef, but they can also be a cook, as far as their product is concerned, right? Because I feel like a lot of the business, looks at them, a lot of the companies look at themselves, we're the chef. You should connect everything to us. We are the center of the universe, right? So this sort of center of the universe mentality, universes don't really have a great interaction if they interact, right? So it's kind of chaotic, and it's where leading to the concept of this whole API. I think bringing up the API thing is good because, it just seems like the resistance comes from this, need to be in control, right? Or having this access. But that's happened in the automotive industry too, right? There was a point where there were no standards for talking from this device to that device. Now, if you don't communicate on that standard, you can't even play in a car factory. So it's kind of like, I feel like we need to reach that step of just communication standard at the very basic level of where we're not like, battling out. Well, we only talked with this, because even APIs are totally inconsistent in this industry. They're all over the map. And there's a lot of standardization in automotive. It's like, if you don't write your API to deal with this, type of commands formatting, it won't play either, right? I mean, we don't have those rules yet, I think.
Yeah.
Yeah. But we'll get there. I think we'll get there.
Absolutely. I do think that's almost inevitable. And I think of like the personal computer as kind of being a model for where lab automation hardware needs to go. In that, in yield early days of the personal computer, every processor was so deeply unique and the layers on top of it were so deeply unique that the software was just
really great.
You have software that works on IBM or you have software that works on this other device, and they have absolutely no overlap there. Whereas now, there's been more consolidation in the market, and more or less people have a Mac or a PC, and don't talk about Linux. But
Yep.
But now, like when you release software, you release it, generally speaking, on both devices. Sometimes it's specialized in one or the other, but PCs in particular, right? We have had so much progress in the world of software because the underlying infrastructure is far more accessible. Right?
Yeah.
I can be at home writing software that can be deployed around the world if I
That
if
is
I wanted
amazing.
to.
Yeah.
Um,
Yep. Yeah.
and I went to this really sweet conference hosted by some folks at the University of Washington that was all about pathways to open source automation hardware. And like academics come from a very different perspective on this stuff, but we had some really neat conversations. And there were some things that came up that I realized could become standard with industry. So for example, what if liquid handlers in general as a product were more modular, and you could buy your Hamilton, you could buy your TCAN, but also when another company comes out with a specialty head, it is, interchangeable with a device, and you can stick your special third-party head onto your Hamilton. And then you can have entire companies spin up around really optimizing like pipetting technology. And you can have, like the Lynx came out with a really cool normalization head and whatnot. But we're really limited by being locked into these environments. And right now, I think the battle line is on like work cells. Like, can we combine a bunch of devices from different vendors on a single work cell? And we can, but it's getting easier, right? And there's a case to be made for bringing that battle kind of more into the weeds. Like, why not change out, the GPU on your PC, right? Why not change out the liquid handling head, the plate rating technology? We could be getting to a world in which the technology is higher quality, can do more interesting things, and more robust because we get a little bit less precious about owning the entire market.
For sure. I mean, and I think in all fairness to the vendors also, I think there's a market for the gaming PC. There's also a market for the Mac Mini. The completely closed, don't touch it, and the do whatever you want with it. I think there's a market for both, and there's a usefulness for both. It just, even if you kept that the way it is and you just standardized on the stack between the baseline hardware and what I talk to, right, and optimize and what I can work with remotely and how I work with it remotely and how I can interface as part of an overall workflow management software, whether that's in-house design like Ginkgo, right? I mean, they, created this whole cloud-based, it's a cloud-based software that Ginkgo developed.
Yeah.
I mean, look, when the market doesn't provide, they're going to come up with their own thing, right? And it's just like, I think that's also pushing in a different way for more of that. So I'd love to see more, standardization in that way to open things up. But as we're starting to wrap up, and it's been a great discussion, if you could design your dream automation challenge, what would it be?
Ooh.
Oh. Yeah.
Speaking of challenges,
a lot of ways.
And while you're thinking about that, I also think that the pick of the week segment's coming up.
I think the thing I'm most fascinated by now is what is the next Rex, right? Like, I got to work on this very cool technology where we were approaching automation from a very different perspective and working this unique place of both getting to play with the technology myself, but also advocate for how it can be stronger. And we're almost like a technical generation beyond that, almost. And I would love to do it again. I think continuing to iterate on what we can do with lab automation and what it looks like and how we can fundamentally improve the way we're interacting with it is really fun.
Yeah. Well, I mean, like you're saying maybe getting back into the automation, kind of oscillating between your current project and working in the lab again. I don't know. Maybe we should all start a company here.
There we go.
Building the next rack system. I know. We're like, what if we started another company? But
investors, if you're listening.
Yeah, right. No, and I was, it's so funny, like, thinking back in the day, you're talking about like PCs. The fact that like Windows is running on ARM processors now. That's I couldn't even fathom that. 15 years ago, I was like, that's just wild. My phone runs on ARM, my Mac runs on ARM, and now I can get a PC that runs on an ARM processor. So look at that consolidation. So we are getting to our pick of the week segment, and the pick of the week, if I don't know if sort of how much briefing you gave, but it's in the show notes. It's like if you have a surprise, yeah.
It is in the show notes.
Well, I mean, it was in the show notes, right? But the pick of the week is just an idea, a website, software, a music playlist even. Is that the first time you put that one in?
It is the first time.
That is the
yeah.
first time.
I try to change up the script for Mike a little.
Yeah.
It could be anything. We always let the guests go first, but if you need a minute, I know Mike always has something.
Not always, but yeah. I do this time. Sura probably knows what it is. Any thoughts, Madeline?
Oh, sorry. I thought you were going to jump in. Okay. Well, I do actually have something. So I grew up a New Yorker. When I was a little baby child, my parents would take me to the Museum of Natural History whenever it was raining instead of the park to make me run out all my energy. And I just went back and visited again now that I'm back in New York as an adult. And there's one exhibit at the Museum of Natural History that is by far the scariest thing in the entire museum that I am confident was put there entirely to terrify children.
Oh.
So if you go into the big room with all of the ocean life, in the far back corner on the left, behind some stairs, it's the only exhibit that doesn't have any glass in front of it. It's very dark and very spooky.
He's setting it up really well.
Giant squid fighting a sperm whale in the darkness. And it is straight out, like, it gave me nightmares for years in the best way. And so I went back and revisited it and got to watch a bunch of other children, I believe, having their own formative memories of this nightmare. So
they wanted to make sure no kid will forget this museum.
Dark?
It's in the dark. And this whole room, so it has a bunch of like dioramas basically of animals, and all of them have glass in front of them, which is normal for museum. This one doesn't have glass, which is how you know they specifically set it up to be scary. And you'll watch people walk by, little kids, but also adults who are trying to look like they're too cool to be frightened by it. And they'll just kind of put out their arm a little bit to see if they can touch the glass. And then they'll kind of back up when they realize there's no glass there.
No glass.
Yeah, you feel like you could kind of slip straight into, some horror story.
And the darkness is probably for accuracy, right? The darkness, like this is the sea. This happened in the sea, so it was dark. Yeah. That's funny. And
my only complaint is they now put someone there who their job is to shine a flashlight and make it less scary for little kids. And I think they're going the wrong way. I think they should make it more scary.
That's what makes. That's what makes the place memorable. I mean, come on. Damn. Yeah.
That's a fun story.
That is cool. Yeah. I
got nothing. That's all you, Mike.
You got nothing? You got nothing? Does anyone remember the SLAS in 2015 that was where they went to it was DC and the
museum.
Air and Space Museum was the that was like the big event, the Hamilton party, right? That was the Hamilton party. And anyway, it was funny because as I'm walking in, there's ICBM right in the front entrance, an ICBM missile. But that was cool to be having beers and hors d'oeuvres in the Smithsonian. That was pretty cool. So this industry's not bad for the places it takes us. I turned a lot of corners
in that museum that I was freaked out.
Yeah,
for sure.
A different kind of horror.
Different kind of right. Well, my pick of the week is handheld. So some of us are video gamers. Sura and I are video gamers. And anyway, I took the plunge, got into a wait list for it.
The Switch 2.
Yeah, right. The Switch 2. Yeah. So anyway.
And what are we playing?
A combination.
What does it look like?
Yeah, here, let's see here. A combination of some old retro. I mean, I have Mario Kart World, which is the only game that came with it, right? But, I've got some retro games on there like Rolling Thunder. That's like 1980s right there. Mortal Kombat. And what else we got in here? Oh, and this is one of my favorite. The Nintendo's games, 51 games. So it's like a bunch of classic games that they've rolled up into one. This is probably where I spend most of my time. I think it's what I like most about the Switch is just Nintendo has this incredibly good knack of making something that's fun, easy, pretty much any age group. Because I always look over, it's like, you've got one too. Okay, yeah, so somebody my age who's also playing a Nintendo Switch. It's more.
That has me wondering what anybody has Doom running on an XPL yet.
Yeah. You can.
I'm very curious, what made the jump to go from? Because I'm still using my Switch. Why did you get a 2?
Well, so, okay, I'll give you a great example. The Mortal Kombat's a Switch 1 game, right? But the processor in the Switch, the original Switch, is probably just burning up as it's trying to run that game. And it also is slow. And so, like, I booted it up on this thing.
I mostly play the dance games.
Yeah, okay. Well, then you don't need it. You really don't need it.
You got some Nintendogs on there?
Oh, because I have a kiddo, right? It's the easiest thing to do.
Call of Duty
I'm very excited
days
for
are
you.
over. Yeah, well, no, it's...
No, that's the PS4.
Yeah, they don't do Call of Duty on Nintendo Switch. That's like, if you want to do... That's a PS5. Actually, you can still play it on the PS4, just the load time. Anyway, so, Elizabeth, any
Elizabeth?
thoughts on a pick of the week?
No, I don't have anything today.
We're such bad hosts. We never have anything all mic all the
And
time.
we know.
And we know it's coming every week.
Yeah. Well, it's become tradition. It's. I mean, plus if we had 10 picks of the week, you know, because we don't have a limit. It could be more than one pick of the week if we did it. So anyway,
Yeah, we've had guests that have had like 5.
who is the record? I'm trying to think.
Mustafa.
Yes, that's right, Mustafa from Automata. He was
Followed
probably
closely
has
by
the record.
David.
Yeah, just one book, website, another book. Yeah, podcast. So, well, thank you again for joining us, Madeline. It's a pleasure to spend some time with you and learn about what you're doing. I think it's really awesome bringing out that knowledge to folks that want to learn about it, and it's a market that frankly it's only going to grow. this industry itself, and so. If any of you are listening, as I said earlier, well, of course you're listening because you're hearing me right now. But just a reminder to visit Madeline's website, theautomatedlab.com, and to learn more about Helical Brew at helicalbrew.com. You can see us on our YouTube channel at youtube.com/ I don't know why they make you put the @ symbol in there, but it's at Helical Brew. Just type in Helical Brew in your Google browser and you're guaranteed to get us because we only have a brewery that fights for space on our first page Google search results. So with that, I'm going to say, as I have come to be known for, this episode of Helical Brew is brewed. We'll see you next time. Bye-bye. Thank you for joining us on the Helical Brew. We're glad to have you with us. For more episodes, please visit our website at helicalbrew.com. That's helicalbrew.com.